Good morning. Thank you for joining us for our speaker series, Toxicology in Societies, the Impacts of Chemicals in Our Lives. I'm Ruth Sofield, an environmental toxicology and chemistry professor at Western Washington University, and my co-host is Tracy Collier, hi Tracy, a toxicologist who is retired from NOAA's Northwest Fisheries Science Center and continues his work as a consultant. We would like to begin by acknowledging that we at Western Washington University are on the ancestral homelands of the Coast Salish peoples who have lived in the Salish Sea Basin throughout the San Juan Islands and the North Cascades watershed from time immemorial. Please join us in expressing our deepest respect and gratitude for our neighbors for their enduring care and protection of our shared lands and waterways, the Lummi Nation and the Nooksack tribe. And now I'd like to go over a few logistics. We'll save questions for the end of the presentation, but you can use the Q&A feature on your screen at any time. You will be muted throughout the presentation, so we will use this feature to interact. The focus of our speaker series is to provide understandable examples of how events with a toxicological component have consequences to people and societies. Today, we are delighted to welcome Dr. Max Learn, assistant professor at the new College School of Mathematical and Natural Sciences at Arizona State University. He is also a senior global future scientist at the Julie Ann Wrigley Global Institute of Sustainability and a faculty affiliate at the Arizona State University Banner Neurodegenerative Disease Research Center. Today, he will present his work on contaminants in cannabis. Welcome.
Thank you so much for having me, Dr. Sofield, and thanks a lot also to Dr. Collier and for you all attending the webinar today. Today, I'm very excited to share with you all about my research on environmental contaminants in cannabis. Now, before I start, let's have a quick overview of the status of cannabis legalization in Arizona, where I'm from, and across the US. Now, currently in the US, we have over 200 million of Americans currently have legal access to medical cannabis, recreational cannabis, or both. Now, in Arizona, where I'm from, we actually have this Smart and Safe Act. Okay, Smart and Safe Act. This is actually the bill that was passed in 2020 when I first started at ASU during the 2020 ballot, and it's legalized the recreational use in Arizona. Now, there are legalization at state level across the US for the past 5-10 years. And in addition to cannabis legalization, I got okay, interesting. I'm so sorry about this. I'm really sorry about this. Can you all see the slide okay?
Great.
Okay, sorry about that. Okay. The cannabis legalization provide access to the population living in legalized state cannabis, either for recreational or for medical purposes. However, we also have cannabis-related products such as CBD, cannabidiol, which is not a regulated because of its content. It is not. It doesn't contain delta-9 THC, or it's below the cutoff. It is available to the rest of the population in the US. So the overall implications of this is that right now in the US, our entire population are having more and more access to cannabis or cannabis-related products. And this is the big picture that we are dealing with in the context of environmental health. Now here I'm showing a couple of headlines that is about cannabis contamination in the news. Now in last year, in April 18, 2022, we have a report. We have a report from the Arizona Republic. That's a newspaper in Arizona that broke out a investigative story about a cannabis manufacturer trying to falsify the cannabis testing. Now, in all legalized states, there are some form of cannabis testing requirement. And in this case, the manufacturer actually were trying to falsify the sample that are being sent to the analytical lab. Shortly after this news, our lab also published a report in the journal Environmental Health Perspective. And we published out the first comparative state level regulation analysis. And not only that, the report also includes a analysis of the compliant testing result of 8,000 cannabis flower and extract that are submitted for compliance purposes. And after after this report come out, there are a couple of other new outlets that actually pick up both at the state level and at the national level. So with the legalization process, people are getting more interested. People are getting more interested in the topic of cannabis legalization and the safety issue. I expect that there will be more coverage on contaminated cannabis in the foreseeable future in the news. Now, when we talk about environmental contaminant, now what are we actually talking about here? What chemical are we talking about? Now, there are 4 categories of environmental contaminant: pesticide, solvent, metals, and microbial contaminant. We'll go over this one by one. Now, first of all, let's talk about pesticide. Now, pesticide include insecticides such as chlorpyrifos. I think to this audience, chlorpyrifos is a compound that you guys have heard a lot about, and also mycobutanol. Now, mycobutanol is a fungicide, and basically what you're seeing here in this 2 pictures, on the left-hand side, you're seeing 2 spotted spider mites. Now, this is a devastating pest that can infestate greenhouse. And basically what happened is that in a greenhouse facility, if you have any of these mites that go into your lab coat and you get into the greenhouse and it infestated the greenhouse, it never get out. Like this is really invasive kind of a pest. And usually in commercial lab, people actually growing, things like corn or wheat, commercial cash crop, commercial lab, like they actually have lab coat and everything that are autoclave before people operate in this facility. But that's usually not the standard for a cannabis lab. So when you have a pest like that, the only way to get rid of it is to fumigate it with insecticide. Now, on the right-hand side is powdery mildew, now, which is what is showing here on the cannabis list. And basically, what happened is that when people are producing cannabis, you see that's the flower that you will see in the dispensary, right? If it's too dry, the flower will crack open. You cannot sell it. And if it's too moist, then you would have fungal contamination problem, such as powdery mildew. And let's say if you have a room in which the drying and the curing process is taking place, if you have a contamination with powdery mildew, overnight you can destroy a massive amounts of crop, like in the size of the servo lecture room, like in scale. This can grow really fast, and this actually destroy the crop right at the final stage of production. So that's why there's need to use chemical like both the insecticide and fungicide for production purposes. Now, another issue I want to bring up is that we are talking about, for the most part in this lecture, contaminant in legal product. However, it's also important to realize that there are illegal cannabis, and for illegal cannabis, first of all, there's no testing or requirement whatsoever because they are illegal. And second of all, sometimes this chemical can be added intentionally as spike. Now, for example, there's this paper coming out from Brazil in 2015 about a herbicide paraquat. Now, many of you would have heard of paraquat if you are toxicologists. That's a model chemical that will be induced neurodegenerative phenotype experimentally. It is also found to be at a dry weight ratio of 2.5%, 1 in 40 in one illegal cannabis sample. Okay, so this is also one area that illegal cannabis. That's also another big concern in terms of cannabis contaminant. I want to talk about the second category, which is the microbe and mycotoxin. Now, these include E. coli, Aspergillus, and Fusarium mycotoxin. Basically, these contaminants can be introduced in cannabis in growing, processing, and storage. And the big concern with the pathogen is that it can cause opportunistic infection. Okay, and for the mycotoxin, particularly for the Fusarium mycotoxin, which is not regulated at all in the US, it can have neurotoxic effects. Here, what I'm showing on the lower side of this slide is a report coming out from CDC. And basically, they find a correlation using the insurance claim data, cannabis use, and also the fungal infection in the patient. Okay. So metals, yes. Metals include lead and magnesium, and these are elements that are naturally sequestered by cannabis. This cannabis is a sequestering plant. It actively taken element from the environment just as a part of its growing process. Now, one issue with metal contaminant is that it doesn't only come from plant, but it can also come from the packaging material. For example, lead were found to be, in one case, leaking from the packaging material, specifically from the plastic cap. Okay, it leaked into the oil. So many of these metal contaminants have potential neurotoxic effects. Now, finally, I want to talk about solvent. Now, solvent include things like butane or propane. This is the residue of extraction process. Now, here on the left-hand side, what I'm showing is a jar of acute cannabis extract. I actually took this picture myself in a facility. And basically, what you can see here is that the cannabinoid in the pure form, it basically have a wax-like texture. It's very dense. So depending on how the extraction process is done, if it's a top commercial facility, usually they would use something like a CO2 extraction method, and with that there's no residue because it's CO2 driven. But for the other extraction process that involves solvent, particularly with illegal cannabis, the residue of solvent is a big concern, and they have potential neurotoxic effects. Okay, so that is the background on what I'm interested to talk about environmental contaminant. What are we going to talk about today? Now, first, I want to talk about the current status of state-level regulation of cannabis contaminant in the US. Second, I want to talk about the potential interaction of cannabinoid and pathogen. And third, I want to talk about health risk to neurological patients. Specifically, I want to use Parkinson's disease as a case study. Okay, now we talk about the legal status of cannabis in the country. Now, in terms of the regulation of cannabis contaminant, right now there are two layers of regulation. Now, the first layer, federal regulation, is non-existent because it is being listed as illegal, a Schedule 1 substance. So a Schedule 1 substance would basically be like things like heroin or LSD, right? We don't ask about the contaminant in those substances because just don't touch it, okay? But cannabis is different because cannabis is illegal at the federal level, but at state, they're legalized program. So right now, there's no consistent unified regulatory guideline to mitigate the public health risk associated with cannabis contaminant. Second, individual state level regulation. Now, this really is where the line is being held, okay? State individually implement their own policy and regulation for cannabis contaminant. And we'll talk about sometime to talk about how this actually works, like on a national scale. Now, in this study, we examined the contaminant regulation of all 36 states. Now, this data set is as of May 18, 2022, last year, okay? And we are examining all 36 states and also Washington, D.C., okay? Like all of these jurisdictions have legalized cannabis. Now, we are specifically asking 3 questions. The first question that we ask is, how many contaminants are regulated in all of these jurisdictions in the US and in individual jurisdictions? Okay. The second question that we ask is, if you break down the contaminant regulation by category, by the 4 categories that we talk about, how are they regulated differently? And third, the discrepancy in the regulation in different states, how can it affect cannabis users? And this work is primarily done by 2 members of my lab, Laura Jamieson, who has now moved on as a PhD student at Duke University, and also Kendra Conwell. And this work is published in Environmental Health Perspective. Now, first, what I'm showing here is a Sankey diagram that shows the total number of contaminants grouped by category, subcategory, and the chemical class of the contaminant that are listed by the 36 states in Washington, D.C. in the regulatory document. Now, what I'm showing here is color-coded. Pesticide is in blue, and then you have solvent, green, microbe and mycotoxin, inorganic and other, okay? And what you're showing in this bar is proportional to the number. And you can see that pesticide by far is the most, by the number, is the most regulated category of contaminant. But there's one important caveat here. If you look at the breakdown of individual state, the average number of regulated contaminant in each state, in each jurisdiction, is about 150. But in total, you have 679 contaminants, and then and over 500 pesticides that are being regulated. So what does that mean? What does it mean is that if you look at the individual contaminants that are listed by each state, there's huge variation of what each state are actually regulating. Now, let me look further into each category. Now, what you're seeing here are the number of listed contaminants. They're grouped by different categories: pesticide, solvent, microbial contaminant, and inorganic and mental contaminant. Now, what you're seeing here on the x-axis is the number of listed contaminants in each state. Okay, so you have a state that doesn't provide any specific pesticide contaminant in their regulation, and you also have state listed 400, right? And then on the y-axis is the number of states that list such range of contaminant in their regulatory document. We'll go over this one by one. Now, first, let's talk about pesticide contaminant. Now, here, what you can see is there are a number of states, about 14 of them, they regulate less than 50 contaminant. But then it go taper off, right? There's one state that regulate close to 200, and then all of a sudden, there's another group of states, about 5 states, they listed 400 or so contaminant. Now, why is that? The reason why there's this outliner here is because all these 5 states, instead of listing specific contaminant, they actually have a language in the regulation and say that, okay, we are going to take the full list of the US EPA maximum residue limit. Now, this is how they call it actually in Europe, but here in US, we call it the tolerant level, okay, for food commodity. And we regulate all of them. And that is a one-liner without listing any specific pesticide contaminant. This is how it's being regulated in those states. The other states, they have their own list of contaminant, of pesticide contaminant, which we are regulating. Now, the other category I want to talk about is the solvent contaminant. Now, this again is similar to the pesticide contaminant in terms of distribution, right? You have some states that regulate less than 5, a good number of them regulate less than 5 solvent. But then you also have states that listed over 50 solvent contaminant. And I believe Arizona on the high side. Not sure about Washington. I think looking forward to chat about it after this talk. But you can see that some states don't list any are listing less than 5. Some states list a really high number, and it's the variation that we're interested in here. Third category, inorganic contaminant, include metals and arsenic. Now, this is the category by far that have the highest consistency. You can see that all states, if the state is at all listing any inorganic contaminant, they would at least list arsenic, cadmium, lead, and mercury. Okay, these are the big four. And depend on the state, like some state will also regulate a higher number of inorganic contaminant, but there are consistency in all the regulated states and think that okay, these four contaminants they probably should be tested. Okay, and then you've got a number of states that don't list any specific organic contaminant. Now, last but not least, I want to talk about microbial contaminant. Now, microbial contaminant is very interesting because you can, for all the contaminant that we listed on the other side, usually you're talking about a HPLC or GCMS type of analysis that cover a large number of contaminants at one time. Okay, but microbial contaminant, with the exception of mycotoxin, there are so many different ways that you can test for microbial contaminants, and so many different microbial contaminants, different pathogens you can test for. So you can see, if you look at the distribution here, is almost looks like some sort of normal distributions. It is you can see that there are states that are not listing any specific contaminant. Specific microbial contaminant, but you also have states that listed over 15 or so contaminant of a specific species of concern. So this is the category by far that have the highest variability. Now, that's the variability, right? Then you ask, okay, what is the public health implication of this? Now, if we take the data set of 8,000 cannabis flower and extract sample that we got from California, and then we extrapolated it across the rest of the US. Now, this is what you will see. Basically, this is a hypothetical. This is a hypothetical situation. It's a simulation, right? In California, based on the regulation, and this is obviously a bias analysis. So you take that batch of 8,000 sample and you run it hypothetically against the guideline of California testing, you will see that they actually they basically capture almost all of the cannabis sample that have detectable contaminant in the compliant testing. Now, if you're looking across the US though, this is where things become really interesting. Now look at the number, the color scale here, which indicate the percentage of contaminated cannabis flower and extract that will pass the listed action level in each state. Okay, you have states that are not as stringent in their level. Usually, they don't list, the kind of contaminant that was detected, in this case, and then a lot of them, would actually have, almost all of them would go to the market, right? The guidance didn't capture those contaminated product, but you also have states that are more stringent and they would capture most of those contaminated sample and then they won't go into the market. The key here is that there are inconsistency in the regulation, which is unique because the inconsistency actually it shouldn't happen. This is one agricultural commodity, right? This is one species, cannabis sativa. If I buy a watermelon, there are pesticides in the watermelon, but the guidelines that are in that one agricultural commodity, if I go to Nevada, whether I go to Washington, whether I go to California, it was the same guideline from US EPA on how to use the pesticide, from USDA on the level that is being monitored, and from FDA if any outbreaks happen, right? That federal guidance and oversight. But that's not the case in cannabis. So that is a reason why we're seeing this inconsistency. Okay, second part of the, and thank you, Danielle, for the comment. We'll respond that at the end. Thanks a lot. The second part of the presentation, we're going to talk about the potential interaction of cannabinoid and pesticide. Now here, what I'm showing is a report from the National Research Council in 2017. Now here, now this report is a couple years old now, and more than 5 years old. And in fact, since 2017, with the federal funding, with NIDA, another agency, the whole cannabis research is just exploded. There's a lot more literature coming out, like since then. Now, the relevance of this report, however, is that it actually provided a list of 21 cannabis treatable diseases. Now here, I'm not talking about the disease that actually can be treated by cannabis, but I'm talking about a disease that actually have been studied and discussed for potential use of cannabis. Okay. And as you can see, this is a really long list. This is a list of 21 diseases. And if you look at the list, there are a good number of them. Almost there's the majority of them have something related to is neurological, right? Is neurological. There's some psychological condition, and the concern here is this: because we talk about cannabis use so widely, like for medical purposes for different diseases, and at the same time, there inconsistency and no federal oversight in how it's being regulated. So one concern specific to the environmental contaminant in cannabis is that the use of cannabis with such a variety of conditions and this can potentially expose patients to with susceptible neurological condition to harmful contaminant. Right? That kind of the implication of the lack of the lack of regulation together with how we communicate the use of cannabis in total, like for medical purposes. That's the potential concern, the public health implication here. Now, at this point, there are no guideline animal tests to test for the combined toxicity effects of cannabinoid and pesticide that I know of in the literature. So how do we go about to look into the potential neurotoxic effect? Well, I mean, we have predictive toxicology now, right? For those of you who are in this audience, you must have heard about it. Predictive toxicology, system toxicology. And this is the approach that we take to look into this issue. Now, first, using what we have from the literature, the knowledge that we have from the literature, we will create a cause and effect model. Like for those of you who are toxicologists, you must have heard about, adverse outcome pathway, AOP. We'll talk about it in a bit. We'll create an AOP based on existing knowledge in the literature. Now, second, we will also examine the effects of cannabinoid and pesticide on neurotransmission in the model organism C. elegans. Now, in this work, the first part of this work is done by 3 members of my lab, like with Laura Jameson, Kendra Conroe, and also the winner, Pinkasova. And she's currently an MD student in Creighton University. Now, in this research, the first thing that we did is to use a database which is probably quite popular among those of you who are in toxicology, comparative toxicogenomic database, CTD. And what this database is, to those of you who are not toxicologists, are a database that contains curated interaction amongst inferred interaction from the literature. Now, what do I mean by inferred interaction? Now, basically, for any paper that comes to in the open literature, usually they talk about there are 4 different components of information, toxicology information, which is what chemical it is, what gene it is, what phenotype the study is talking about, and what disease the paper is talking about, right? So C, G, P, D. Now, there are 4 inferred relationship, interaction based on what we can see in the literature. The interaction between the chemical and the gene, interaction between the gene and the disease, interaction between the chemical and the phenotype, and also the interaction between the chemical and the disease. Okay, so the 4 interactions. Now, in this analysis, we are constructing what Dr. Kelly Mattingly from NC State would call a CGPD tetramer. So basically what it is that if we have, if we look at the entire database for the 4 components of information, and we basically try to look at the interaction of these 4 components based on the database. And on top of that, we also look at the gene phenotype relationship from the gene goal annotation in the NCBI gene database. Okay, this is the one highlighted in green. And basically from there, although there is no study right now to look at combined toxicity of cannabinoid and pesticide, but just by the literature right now that are available, we can evaluate the weight of evidence of chemical and gene interaction. And in this particular study, what I did is I visualized the interaction between chemical and gene in a hypothetical situation that if we have patients with seizure or epilepsy, if they got exposed to contaminated cannabis, what would be the gene and gene environment, the gene environment interaction involved that would lead to adverse outcome. Now, if you visualize a network like this, what you actually would get is almost like a hairball, right? Because there's so many different kind of connection, even just talking about like 2 components, right? Gene and chemical. Now, what this network is showing, this is a quantitative network, a quantitative network visualization that show the relationship between chemical and gene target. Now, you can see that both the arrow and the node itself, right? There are 2 nodes here, chemical and gene. Both the nodes itself and the connection, the edge, right? For those of you who are in network science, the edge, are weighted by the number of connection, which is linked to the actual paper that actually talk about the connection. Right? So in a sense, this is a data availability analysis based on the available literature of what the literature in CTD is talking about different gene and different chemical. All of these connections are linked to the gene, the chemical that are associated with seizure and epilepsy. Okay, this is basically what we are showing here on the right-hand side. And you can see that, okay, there are different color here, right? What does this different color mean? Well, the color here indicate the classification of the biological function of the gene target. And there are 5 different classifications, right? You have the synaptic signaling pathway, we will talk about it in a bit, the one in pink. You have the MKP, you have the MAPK and also the PICK AKT signaling pathway. Okay, and this is indicated by in green. You also have the neuropeptide hormone activity, the red dot process, right? Last but not least, this is actually really interesting. The ATP binding cassette ABC transporter and also the solute carrier transporter, SLC. So in this diagram, basically what it is showing is the gene, the chemical, and how do they interact with each other. You know, let's say like in a hypothetical scenario, people do got exposed to this chemical in contaminated cannabis. So you can see there's a lot of chemical here, right? So I've got a question for the audience right now. Can any of you spotted anything specific about the chemical that are being listed in the network? I guess you guys can put in your response in the question and answer tab, the Q&A tab. Just put in your response here. Is there any a member of audience want to point out what the chemical is? You can just put it in the Q&A box. How about this guy? Now, all of these belong to the chemical class of organophosphate pesticide. Okay, in fact, like a good number of pesticide or a good number of chemicals that are on this network actually all point to organophosphate pesticide. Now, there is an important reason why organophosphate pesticide are being predicted, you know, based on this data set as a category of contaminant of concern. Now, here is an other system model. This is actually a adverse outcome pathway that I published when I was a scientist working for the cannabis program in in the California Department of Pesticide Regulation. That was right after the legal cannabis recreational law was implemented. And basically what I have done, in this AOP is that I surveyed 125 papers in the open literature that talk about the key events that are linked to the potential interaction between cannabis, between the organophosphate. Now here we're using copairophos as an example, and cannabinoid. And basically, for those of you who are not familiar with AOP, AOP is a cause and effect model. The idea here is that although there are no study to actually connect the exposure to both cannabinoid and copairophos, and in this case, we're looking at the exposure in pregnant women, prenatal exposure. There's no study to even, to study this at all in animal model even. But because we do know how the chemical interact with their molecular target, what the molecular target is doing at the cell, how the cell would respond, and how the cell respond at the tissue level. You see, it's an emerging level of biological organization. We can list the information one by one according to the level of biological organization and make the prediction that the effects of the combined, in this case, concomitant exposure, the concomitant exposure, this would lead to a potential adverse outcome in long-term deficit in learning and memory. So that's how the cause and effect model works. And this report, at the time it published in 2019, is the first report published by any U.S. public health agency on the potential hazard of cannabis contaminant. Now, here I want to talk specifically about the what the cannabinoid and the pesticide are doing at the synapse. Now, here I'm showing the component of the synapse, including the pre-synapse and the post-synapse. Now, I want to highlight the components that are color-coded here. Now, first, when we're talking about synapse, one of the main things that we are interested in is neurotransmission. Neurotransmission indicate that you have the neurotransmitter going from one side going to the other side, right? That's how the neurotransmission works. However, that's not the only thing that happens. We also have phytocannabinoid, which actually can go from the opposite direction. It goes from the post-synapse to pre-synapse. That's why the endocannabinoid pathway, sometimes it's also called endocannabinoid retrograde path. It goes to the opposite direction, from post-synapse to pre-synapse. Now, okay, so we talk about what the cannabinoid work, right? How about the organophosphate? Now, organophosphate, what it does is that it interacts with a class of enzyme in the synapse known as serine hydrolase. So serine hydrolase are important in the endocannabinoid retrogradation because it basically acts as a kill switch. Okay, if you consistently have endocannabinoid that are being secreted from the post-synapse, you're going to keep stimulating the pre-synapse, right? So the serine hydrolase actually eliminate the endocannabinoid. But what happened with organophosphate pesticide is that it can inhibit the serine hydrolase. So the endocannabinoid is already there, and on top of that, you have the phytocannabinoid, such as delta-9 THC, they keep kicking in. So what happened is we actually have a combined effect of these two chemicals, and that is the potential. This is the predicted mechanism of interaction based on what we know from the literature. Now, I also want to talk about some preliminary work with my favorite laboratory model, C. elegans, which I have been working on since I was a graduate student at Duke. What I'm showing here is a life cycle of a C. elegans going from the egg stage to adult stage. And you can see that the entire life cycle of the worm takes less than 3 days. So there's tremendous opportunity here for studying neurodegeneration. Specifically, if you're looking at the head region, this is the head region right here with the worm, right? You can see that there's this apparatus here, right? This is the dopaminergic neuron highlighted by the green fluorescent protein. Remember paraquat that we talked about in the beginning? If you put the paraquat in, it completely wipes out the structure of the dopaminergic neuron. Okay, this incidentally is also the neuron that involved with the pathology of Parkinson disease. We will get back to India. And with this work, I want to highlight the contribution of my student, Laura Jameson, who has moved on, and also with Albert Rivera, who is the winner of the 2023 EMGS undergraduate research scholarship, and also Ariel Stephen, who implement all the, who actually converted the essay that we do, in the class that we teach at ASU. We don't just, teach experiment, as an academic exercise. We try to show the student how it actually works in a practical sense. Now here, what I'm showing here is the 2AG treatment, which is an endocannabinoid in C. elegans. And basically what I'm trying to show is, if the 2AG by itself, you can see that even at a high concentration of 100 micromole, it actually doesn't have much effects by itself to the integrity of the dopaminergic neuron. However, paraquat, if you expose the worm to paraquat, the organophosphate pesticide, is wipe out the structure, and also it does intensify the effects. The effect does get intensified in the presence of endocannabinoid. So basically, this is a small effect. We actually have done some preliminary quantitative analysis. We think that the additional effect is probably around 10%. We haven't quite titrated the effect for the dose response relationship yet, but the preliminary result indicate that there might be a potential interaction between the two. Okay, now in addition to the to look at the structure of the dopaminergic neuron, I also want to show the repulsive behavioral assay. So basically what happened is that when you have the 1-nonenal, which is a compound that comes with a smell that the C. elegans doesn't like. So basically what you are seeing here is that on the other side of the let's see if we can. All right. On the plate under the microscope, you see the worm here, right? This is the pig that have the 1-nonenal. Okay, and the worms see it, they're like, that 1-nonenal, oh, let's go, the repulsive behavior. But they don't really like the smell. But the problem here is that if the worm was exposed to endocannabinoid, this is what our lab member would refer to as stoner effect. So the stoner effect is there's this speck coming in, smell terrible. The worm got the endocannabinoid exposure. They're like, oh, okay, and then they just stay there. The response got delayed, and which is what you're seeing here on the x-axis. It shows the cannabinoid, concentration, and the y-axis you show the revulsion time. The worm response got delayed. Okay, so this is one assay that we look into specifically as an indirect measure of the dopamine signaling. And this work is still in progress, and hopefully we will have something to report very soon. Now, I understand that I'm running short on time. I'm going to wrap up the last part very quick. This have important implication about the public health education for to mitigate this issue with cannabis contaminant. And I want to attribute this work to a very talented PhD student, Simon Griffin, who is the ASU Presidential Scholar, and he's also this year's winner of the Society of Toxicology Ethical, Legal, Forensic, and Societal Issues Specialty Section Graduate Student Award. So the work that I'm talking about is mostly from her doctoral project. Now, Parkinson's disease is listed as a qualifying condition in 15 states. Now, but that doesn't mean that only in those 15 states Parkinson's disease patients have access to cannabis, because the patient can also self-medicate with recreational cannabis or other conditions that are related to Parkinson's disease in their state. Now, the reason why we are interested in Parkinson's disease is because, first of all, it is used at a high incident rate. Between 25 to 40% of the Parkinson's disease patients are reported to be active user. Now, this is coming from two studies in 2017 and 2021 that from the Parkinson's Disease Foundation and Michael J. Fox Foundation. Okay, so this is the estimate. It is higher than the national average of cannabis use rate of about 10%. Okay, so this group of population they do have they do have a higher rate of cannabis use. And the reason why the Parkinson's disease patient use cannabis is for symptomatic release, to relieve pain, anxiety, tremor, and sleep disorder. So we basically treat Parkinson's disease as a case study. We try to extrapolate. We try to use this as a case study to see how Parkinson's disease would how medical patients use cannabis for medical purposes, and how do they perceive the risk of contaminant risk. And in this study, we are collaborating with Barrow Neurological Institute. So there are two parts of this. We are trying to study the risk perception of patient, of course, but also with the health provider, the neurologist in this case, movement disorder specialist, neurologist specialized to see Parkinson's disease patient. Now, there are three research questions that we're interested in. How do they get their cannabis? Do they at all, are they mindful of using cannabis from legal sources or not? Do they know about the testing requirement of cannabis in Arizona? Do they know all legal cannabis has been tested for pesticide? And also, the last part is important. With those information, how can we educate them, right, about cannabis, about safe cannabis use, and also product safety? Now, what I'm showing here is preliminary, but we reach out to 18 movement disorder specialists and neurologists. These are people that see anywhere between 100 to 500 Parkinson's disease patients per year. And we ask them what's the risk of cannabis use in Parkinson's disease patient, okay? And interestingly, most of them actually say that the risk is unknown. Now, this is really interesting. The usually issue with cannabis is very polarized. Either people say, oh, this is great, let's use it, or people say, oh, this is really dangerous, don't use it. But the physician, based on their response, they're aware that we just have a huge knowledge gap here, right? We just have a huge knowledge gap. We just don't know too much about the risk of cannabis use as a whole. Next question, we ask them what do they think about contaminant in cannabis. Now, this has become really interesting. The majority of them, out of these 18 physicians, 2/3 of them say they don't know anything about contaminant in cannabis. Now, but the one that actually respond to this question, now look at what they know about the contaminant. Many of them, 4 of them actually say that pesticide is a concern. Now that makes sense, right? Because these are neurologists, they know about the neurotoxicity of pesticide, obviously. But they also talk about metal can be a concern. One thing that is interesting to us is that the microbial pathogen and also fungal contaminant, this is not listed as, as many as the other 2 categories. And I think it probably have something to do with training of the physician. Because if you look at the new media, the microbial pathogen and the fungal toxicant, those 2 are the ones that actually come up with the news or not. But the physician, they actually pointed out, okay, the pesticide, the metal, this has problem, probably because of the training as neuroscientists. I'm going to show one last slide and then we're going to end. After this question, we give the physician a slide to show them what are the contaminants that has been found and why they're there. And after that, let's see how they respond to this question. What are the physician's main concern about the health impact of cannabis contaminant in PD patients? First of all, there are a number of opinions that they point out. Some say that it's not really anything different from other vegetable. Some say that the regulation is a problem. Some say that infection is a problem. But the key here is a number of physicians responding to it. Look, the number is actually much lower. They respond diversified. I think that one implication that I have is that because cannabis is being administered in our country without a lot of input from the health provider community, so they actually don't know much about it. But when you give them the proper education, they actually have a lot to contribute. These are subject matter experts, okay? And I think this is an important implication in how we educate the patient and physician on safe cannabis use and product safety moving forward. Okay, last slide. The take-home message of this presentation is that first, environmental contaminant in cannabis pose a health risk to patients, particularly those with susceptible medical conditions. Second, predictive model such as network analysis and AOP, they indicate that the potential combined toxicity of cannabinoid and organophosphate pesticide is a concern. Finally, based on the result, our hypothesis is that if we educate a health provider, the education of health provider is key to ensure all the stakeholders that are involved there is key to ensure safe cannabis use and product safety. With that, I would like to thank all my students and all my collaborators from different disciplines. It really teach me a lot doing this work. And I want to thank my funding support, and I would like to welcome any questions. Thank you.
Great. Thank you so much, Max. There are a lot of questions that were generated both before and during your talk, and some are technical and some are big picture. I'm going to start with some big picture ones, and then actually I'm going to do a technical one first because I think it's a good, you were talking about that to some extent. So this is from a speaker or a guest online, and they say there's an ongoing conversation about whether high potency cannabis causes or is correlated to mental health disorders like schizophrenia. And then there's also cannabis hyperemesis syndrome, which I had to look up. And so maybe you could explain that. But the question is there any data or research out there about environmental contaminants in cannabis and how they may cause these syndromes or disorders? Basically, if people consume clean cannabis, are they still getting sick? And you started that with your example with Parkinson's disease and what led up to that, but maybe you could kind of expand on that since there's without like and kind of as a big picture kind of way of thinking of it.
Okay, so if I can paraphrase, there are two parts of this question. The first part is in terms of environmental contaminant in cannabis, what are the major research going on right now? The second question is why Parkinson's disease? I'm going to take the first part first. So the research with environmental contaminant, with cannabis, with product safety specifically, and also with safe cannabis use, this I refer to dosing in particular, are lacking in the US. It has a lot to do with the way that we fund cannabis, because it's either we're all basically treated as a substance of abuse, so negative health effects, right? And then we treat it as potential use, right? But then we actually do not have a national program that legalizes cannabis and administer it, like consistently, which is the case in Israel and Canada. So in terms of specifically product safety contaminant research, in addition to my group, I think like there's one group in University of Sydney. They actually have a group that look into the use of cannabis in patients with epilepsy, and then they actually tested what is in the cannabis. So that's one study that is going on right now, and I think they actually have another bigger study that is going on. That's the only paper that actually published in this topic right now in the literature. Second, a major group is in Israel. There's a paper, I believe it is in Nature Communication, that talk about sterilizing cannabis and how it would reduce the microbial contaminant just by steaming it, just like milk. So those are the two major research. So that's the first part of the question. Second part of the question, why Parkinson's disease? We want to study it both at the mechanistic level and at the clinical level. And Parkinson's disease have a specific mechanism that we are interested in, and we can study it in the lab. At the same time, the higher use of cannabis, that also has been observed in people with PTSD, with I want to say PTSD and autism. The idea that I'm trying to make is that a higher cannabis use for medical patient is not unique to Parkinson's disease patient. That's why it can be generalizable. We want to study this population as a case study. Then what we can learn, we can apply it to other neurological patient, other clinical population, and we hope to inform health policy and from that point onward.
Yeah, it's a really interesting space to work in.
It is.
So we don't have a lot of time. I'm going to go big picture with this. There's a couple of questions I want to try to string together. And one is just thinking about somebody who might be a user of cannabis, whether it's recreational or medical. And so kind of if you could lead us through in a few minutes, how the levels, how the risk associated with contaminants in cannabis would compare to other products, tobacco or just foods that people might be exposed to. And then is there an organic version available? And then if you were giving advice on what to look for a user, what would you recommend?
Okay, so there are 3 questions here. I try to
Yeah,
make it
3
in a couple of
questions.
minutes. First question is, how does cannabis contaminant risk compare to tobacco and food? Okay, so there are 2 major differences. Tobacco, at least for the most part, we don't advertise it for health benefit, right? Tobacco is, please don't use tobacco, it's bad for you. Cannabis is different. Cannabis, in many states, first legalized for medical use. That is very, very big difference, because that actually go back to one of the take-home messages. We are basically, communicating it as such to patients who have a medical condition, and that might make them more susceptible to the contaminant to begin with. So that's that one big difference. Second, comparison to food. Food, you have USDA, FDA, EPA guidance at different level of production and use. So it is mostly the difference in regulation, right? Because cannabis is there's no federal oversight on those levels, right? But food, each step is heavily regulated. So that's the answer to the first question. Second question with organic cannabis. Now, I actually look into this. Is quite interesting. Is that I think in terms of even organic pesticide, what does that technically mean? I don't think. I mean, I guess I can ask the audience if anyone can educate me, because I don't think there is a definition what that is. But one thing that I can tell you is some pesticides, such as pyrethroid, they can be considered organic because they are not synthetic, right? They're coming from the plant. So organic, for the most part, doesn't actually have anything to do with toxicity. But being organic doesn't mean it's not toxic. Okay. Number 3, what can a cannabis user do? I think the biggest action from the consumer point of view is to to be careful with at least in the state that are legalized. You want to make sure that the product that are being used is legal. The reason why, even in the legalized state, the illegal cannabis, counterfeit cannabis, is still a problem. So, and sometimes counterfeit cannabis, it's difficult to tell the difference. And if it's legalized in most of the states, there are at least some kind of testing guideline. But if it's illegal, it really anything goes. There's just completely no control of what that even is. So I think to actually be mindful of the sources of cannabis is key. Legal cannabis source.
Great.
At the state level.
Okay. Again, there's so many more questions out there. So fascinating topic, but we do have to say goodbye. And thank you so much, Max. And to our guests, we look forward to seeing you next time. Thank you.
Thank you so much for having me, and thank you for your time.
Cheers. Bye.